I'm Charlie. Just the other day I started thinking, what other sources of energy do you humans use? I mean, obviously coal and fossil fuels, but what else? So I did some research. My goodness, Google is amazing. I found out that humans also use nuclear, geothermal, natural gas, and hydroelectric, as you saw in the opening. I seem to be the most fascinated with hydroelectric. It is not a very popular source of energy as it makes up only 2% of Connecticut's energy supply, 6.3% of the U.S.'s energy, and 20% of the world's energy. But it is very clean and slowly rising throughout the decades. As you can see in this graph, the world's hydroelectric power use has increased by almost 3% per year over the past 4 decades. It also increased in the U.S. and Connecticut. For example, Norway's energy usage is 99% hydroelectricity. Norway also generates a small percentage of hydroelectric power in the world. China generates the most, almost of a quarter of the entire amount of power produced. Also, no pollution comes of hydroelectric power, and thanks to one very important man in hydroelectric power, this was all made possible. The most important person in the history of the hydroelectric dams was Lester Allen Pelton, who lived from 1829 till 1908 in Ohio. His first idea was to improve the water turbine wheel by making the Pelton water wheel, which he invented in the late 1870s. He created this wheel to help mining activities have more power without burning and killing all of the nearby trees. This water wheel was designed to extract kinetic energy from moving water in a mountain stream. It had a 90% efficiency rate, which is much higher than the expected 40%. Many people installed his wheel into powerhouses, and he received many awards for his work, such as the Elliott Crescent Medal and an induction into the National Inventors Hall of Fame. Its technology was truly ahead of its time. Even today, we still use his slightly modified ideas. The process of how modern hydroelectric dams work is relatively simple. First, water is trapped behind dams and has stored potential energy. Then, the water is released and it becomes kinetic energy. The water flows down through a chamber called the penstock. While flowing through this chamber, it turns a turbine. After turning this turbine, the water keeps flowing through the tail race and back into the river. The turning of the turbine is connected to a generator which converts mechanical energy to electrical energy. This then could be connected to a step-up transformer which increases the amount of voltage. Finally, it goes onto power lines into our houses. Once a hydroelectric dam is constructed, electricity can be produced at a constant rate, and the lakes made from the dams can be used for irrigation purposes.
Charlie, you can't just expect us to believe that hydroelectric power is all that great. I mean, there have to be some downsides.
Yes, you're right. Dams are extremely expensive to build and require a strong economy. They take a long time to make and have no room for error. By disrupting the water flow, you are also harming the surrounding environment and the habitat of many animals. For instance, migrating salmon are blocked from their path downstream if a dam is in the way. Ah! Phew, that was a close one. Now that we've learned a bit about hydroelectric power plants, it's time to go into the hydrogen cycle. Also known as the water cycle, this process involves rain, oceans, rivers, and all things we know about water. Let's say our water molecule starts floating in the ocean. Eventually, the heat from the sun will heat up the water droplet and cause it to evaporate into the clouds. Once there is too much condensation in the clouds, the cloud releases the water in the form of precipitation, also known as rain, sleet, hail, or snow. The precipitation falls to the earth and becomes runoff, where it can either go back into a body of water or absorbed by the roots of trees. When trees have too much water, they release it into the air by transpiration. This is similar to evaporation. The time it takes for water to go through the cycle depends on where it starts. If a water droplet starts sitting on the pavement, it will take a lot less time to go through the cycle than a drop of water in the ocean. Hydroelectric power and the hydrogen or water cycle go hand in hand. Without the water cycle, hydroelectric power plants would cease to exist. There would be no water for the dams to catch and nothing to spin the turbines and start the generator to make power. Both also have the prefix hydro, meaning water. This shows how similar hydroelectric power and the hydrogen cycle are. Well, That puts our little lesson on hydroelectric power to a close. The important thing to take from this are how the hydroelectric plant works, how the cycle works, and what they do for each other and the environment. Thank you for watching, and never forget the true power water can hold.
I'm blue.